This video is going to be a brief review of slope and what that means and how to find it, and then also how to use that to graph lines. We're going to start with talking about the definition of slope. The definition of slope, and we usually use the letter M to represent slope, is the rise in the run, or delta y over delta x. This symbol is the Greek letter delta. It means change in, so the change in y over the change in x. Well, because this is the y-axis, the rise would be the change in the y values from this value to this value. And because the run is the change in x, and this is the x-axis, the change in the x's is asking what is the distance from here to here. That would be considered the run. Now, if we have a picture and we can just count the units from the first point to the second point, going straight up and straight across, we would do that. Normally, though, we instead are just given the coordinates of those points. So let's take a look at that. When we find the slope of a line containing, in this case, the point 4,3 and the point 2, -5, the slope is the change in y over the change in x. So in order to find that out, we would take one point. In this case, it looks like we're starting with this point, and I would subtract the y's, that's -5 minus 3, and then I would subtract the x's, 2 minus 4. Now notice, if I'm going to start with the -5, I must start with the +2. It doesn't matter which point you start with as long as you use the same point for the first numbers of both calculations. In other words, these two coordinates must have come from the same point. In this case, I get a +4. Well, if I had subtracted the other way and taken 3 minus a -5 over 4 minus 2, I would have gotten 8 over 2, which is 4. Same thing as I got here. So it doesn't matter which order you subtract, you should still get the same slope. Okay, let's look at another one. If I look at this one and I have the points 2, -9 and 6, -9, notice what happens when I subtract the y's on the top and the x's on the bottom. I end up with 0 over -4, so it has a slope of 0. So what kind of a line has a slope of 0? The line is horizontal. Its equation is y equals -9. Let's look at one last example. When the when the points are 5, 4 and 5, -8, notice what happens on the bottom. We get a 0. And we know from just basic algebra that we can never have 0 in the denominator. If you do, you get what we say is an undefined quantity. So that means the slope here is undefined. So what kind of line is that? If I look at these 2 points and think of where they are in the graph, they are directly above each other. So this line is vertical, and its equation is x equals 5. Before we start graphing these lines, let's talk just a minute about how the slope is used to come up with the equation. The slope-intercept form of the equation of a line is the one that we use 99% of the time. If you have your equation solved for y, and you have your x term and the constant on the right side, this number right here, which we use the letter M to represent, that is the slope. This represents the value at which your graph of your line crosses the y-axis. It's the y-intercept. The reason we know this is the y-intercept is if I let x equal 0, I get y equals b, which means the y-intercept is the point 0b. Okay, now let's just take a look at some examples on how we graph equations if it's in the slope-intercept form. Alright, here we go. Sketch the graph of y equals 2/3 x plus 1. Well, first of all, we know that 1 is the y-intercept, so we come to our graph and we put our first point on. We know that 2/3 is the slope, so m equals the rise over the run, which is 2/3. Alright, that means from my y-intercept, or actually between any points, I am going to rise 2 and then run 3. So let's go back to our y-intercept. If I rise 2 and run 3, I end up with this point right here. Once I get that point, I can do it again. I can rise 2, run 3, and put another point if I want. All I really need is 2 points, and then I can draw my line. And there you have our line. Now notice again, here's my rise of 2 and my run of 3. So I go up 2 over 3. Now you do have the option, I could have taken this point, and because 2/3 could also be written as -2 over -3, rising and then going to the right 3 would be the same as falling and going to the left 3. Both of them would give me my second point for my line. Usually we don't do this unless we are up at the edges of our graph and there's really no place to rise. Then we might want to fall and go to the left. Okay, let's take a look at another one. Alright, let's look at this problem. Graph the equation of y equals -2x minus 1. Alright, we first know, in this case, our y-intercept is -1, so we can go ahead and draw our first point. Now, the problem with this one is I have m equals rise over run, and that's -2. I only have one number. Now here's a little saying. If there's no run, then it's a 1. So I'm going to rise -2, which actually means fall 2, and then I'll run 1. So if I go back to my point, I'm going to fall 2 units, and then I'm going to run 1 unit. That's where I'm going to put my second point, and then I'll graph my line. Alright, there you have the line. Notice that this one goes downhill left to right, and the reason for that is the negative slope. Okay. Let's just look at a couple generalizations here. If your line goes up and to the right, the slope is positive. If it goes down and to the right, it's negative. If it's vertical, as we've seen before, the slope is undefined. If it's horizontal, the slope is 0. I actually want to look at 2 more. If we look at the graph of y equals -5, I could think of that as y equals 0x minus 5. My y-intercept is -5 down here, and if I go up 0 and over 0, I'm really not going anywhere. If the slope is 0, then I'm looking at a horizontal line. If you forget that, you can always make an xy table. If you're told that y equals -5, that means that's the only thing you can put in the y column of your table. Put whatever you want in the x column, and all the points that you get are going to lie on this blue line. So y equals a number is always a horizontal line. Okay, here's the last one I want to look at. If you sketch the graph of x equals 8, that is a vertical line going through the x-axis at 8. Now if you don't remember that, this says that x equals 8. So if you're going to make a table, you would fill in 8s for your x column and whatever you want in the y. And all the points you get would lay along this line somewhere. So x equals a number is always a vertical line. So in summary, the slope, which we use the letter M for, is going to be the rise over the run. And the way that we find that is we subtract the y's on the top and we subtract the x's on the bottom. If we get a positive number, then the slope is going uphill. If we get a negative number, the slope is going downhill. If I get a vertical line, that means I had 0 in the denominator, and that's an undefined slope. If I have a slope that equals 0, that means I have a horizontal line. If you have a vertical line, the equation of your line will always be x equals a number. If it's a horizontal line, it will always be y equals a number. If you have a positive or negative slope, then we want to look at the equation of the line y equals mx plus b. The b will tell us where it crosses the y-axis. That's why we call it the y-intercept. And as we've already talked about, m is the letter we use to refer to as the slope. And if the slope is written as an integer and there's no denominator, you put it over 1. When you graph, let's say the slope is 2/3. That means from any point on your graph to the next point, you would rise 2 units, run 3 units, and put your other point. And you would draw your line.